Welcome everyone to the fourth of 5 of the 2026 Bermuda Race prep webinars. Our first was in February and it was an overview of the incident reviews from the 2024 race. The second in March focused on long lead boat preparation topics. And the third webinar just last month focused on how to use the 2025 season to prepare a crew for the 2026 race. And this webinar just now will focus more on the technical aspects of racing, and in particular the Gulf Stream weather and navigation. The final June webinar before we open for entries for the 2026 race will focus on the NOR and NBRSR updates for the 2026 race and on specifics for the entry system. And that's coming up next month. Our panelists for this evening's webinar are Frank Bohlen, Chelsea Freas, and Stan Honey. Frank is a longtime CCA member, Brock member, and a veteran Bermuda racer with 22 races under his belt. Frank's a professor of marine science and a noted Gulf Stream expert. Frank has been guiding the Bermuda race fleet through the Gulf Stream for decades. Chelsea Freas is a degreed meteorologist and lifelong sailor. She's the meteorologist for the U.S. sailing team and has a variety of racing experience from one-design dinghies to navigating keelboats offshore. Chelsea is the founder of Sea Tactics, delivering expert weather knowledge to racers who want to elevate their sailing strategies to gain a competitive advantage. Stan Honey is a longtime CCA member and one of the most recognized names in ocean racing and navigation. Stan has set countless course records around the globe, was the Rolex Yachtsman of the Year in 2010. Stan has won countless offshore races on big boats and small, most recently sailing his Cal 40 Illusion to a victory in the 2022 Newport Bermuda Race. A quick thank you to the many sponsors and partners of the Newport Bermuda Race. Everyone's encouraged to spend a fortune on our sponsors' great products and services. And we're going to hear first from Frank on the Gulf Stream, and then Chelsea on weather, forecasting tools, and finally putting it all together into action will be Stan on navigation considerations. Feel free to post questions to the panelists in the YouTube comments chat section. And after the presentations, there will be some time for Q&A with the panelists. And Kate in the background will be feeding me those questions and I'll pose them to the panel. So with that, Frank, are you ready to kick off?
Well, I hope so.
All right. Thank you.
Well, good evening. I hope you are seeing our friend Homer's depiction of the Gulf Stream. Now, in this uncertain time where we even doubt about taxes and death, the one thing that's for sure, if we're going to Bermuda, is you're going to be encountering the Gulf Stream. And encountering the Gulf Stream, you'll be encountering an interesting natural system. We'll see more in detail in a few moments as we go along. That warrants early preparation. I think you're going to hear from all of us here tonight that prior planning is an important aspect of the race. Races are lost offshore. You might say that the conditions may not be quite as severe as what we're seeing in Homer's depiction there, but there's a possibility of interesting sea state and every now and then you might include some water spouts. What is the Gulf Stream? The Gulf Stream is a component of the large-scale North Atlantic gyre, the wind-driven system that drives circulation in the North Atlantic. And for the oceanographer, the Gulf Stream is that component of the flow that proceeds from Cape Hatteras out to about 50 degrees west. If you look at this picture, the upper sort of the northwest corner there, you'll see the Gulf Stream marked out. And it's an interesting feature, rather narrow, well-defined, as opposed to the rather broad current flows on the eastern side there over by the Canary Current off France. The wind-driven system, just as you can blow the cap off a glass of beer, the wind-driven system tends to blow a certain amount of water in the northern hemisphere to the right of the wind. And as this gyre, this circular pattern of winds goes around the North Atlantic, it tends to favor the formation of something of a mound of water in the center of the basin in the Sargasso Sea. In fact, the elevation of the water, Sargasso Sea, relative to a gravitational reference surface is about 1 meter higher than the Atlantic shelf. And we're going to take advantage of some of these differences in elevation, altimetry, when we try to compute current models. This flow pattern driven by the wind produces what is known as a western boundary current. The Gulf Stream is a western boundary current, doesn't extend all the way to the bottom, as shown in this slide. And it represents a boundary, if you will, between the colder shelf water and the warmer Sargasso seawater. So the Gulf Stream, in the first instance, driven by the wind for the most part, is a sharp thermal boundary. And it's the best way to tell, one of the best ways and easiest ways to tell where you are in the stream is by looking at the temperature patterns. Temperature is important. Temperature, along with salinity, affects the density of the water column, and the density of the water column is another factor that's affecting flow, just as the density of the atmosphere affects pressure, affects the flow in the atmosphere, the winds. Here you take a look. This is a 36 north section running off from around the Carolinas across the Atlantic, and you can see the inshore waters are something like 10 degrees centigrade, coming out to in the 20s, the mid 20s centigrade as we get into the Sargasso Sea. Nice sharp thermal boundary. Now, that wind-driven flow, as it migrates from Hatteras, behaves very much like the flows downstream of a smokestack. Gets progressively more irregular. Here in this basic picture that has all of the features we can look at, the sharp red boundary is the north wall, represents the north wall of the Gulf Stream. It's the main body of the Gulf Stream. The black line is the run line, Newport to Bermuda, more or less. And you'll see that there's a fair meander drifting pattern in the main body of the stream. And that meander pattern has associated with it a number of features that result from a break-off of those meanders. Cold core, that's a trapped parcel of shelf water to the south of the main body of the stream. You see it on the far right-hand side there, cold core feature. And warm core features, which are trapped parcels of Sargasso seawater to the north of the stream. Now, if we look today, more or less, the 4th of May, there's a satellite image of sea surface temperatures. Now, these are all temperatures. And obviously, the coloration is the way I assign color values to a particular temperature. The water out there is from blue to yellow to red. Shows a pretty nice meander in the way of the rum line. Again, that black line is the rum line, Newport to Bermuda. You'll also see, if we looked at it in a little more detail, a number of rings sitting out there. Now, as I come down, typically the stream is located on the order of 200 to 300 miles to the southeast of Newport en route to Bermuda. And as we get down, coming across that nice sharp thermal boundary where we're going from the more or less yellow orange to the reds, you'll see a change in stream flow. So this is a plot of the distance in nautical miles, the x-axis, if you will, the horizontal axis down the bottom, is the distance in from the edge of the stream where the temperature really starts going up. And the flow is in centimeters a second, and everybody knows that 50 centimeters a second is about a knot. So we look at the flow, the speeds beginning to come from next to nothing, typical of shelf flows, slowly increasing, and sort of an irregular pattern to a maximum of around 250 centimeters a second at a distance of about 30 miles in from the edge. That is the classic temperature velocity pattern in the stream. You'll also notice that there is a nice little dip in that as we get out to near 40, and it goes back up 40 to 50. That's also classic of the stream. It's not a solid flow. It's more like filaments, a series of streams, all making up the flow. Now, this is it's a plot of data taken from an acoustic Doppler current profiler riding on the Oleander, which is a regular freight ship coming from New York, to Bermuda. And one of the things to take a look at to get a sense of the variability of the system. Here you are, March 14th, 1998 on the left-hand side. And you see as we get down sort of in the middle, all those long fingers sticking out there. That's the Gulf Stream, the main body of the stream, with flows on the order of 150 centimeters a second, maybe a little bit more. Come back 3 days later and look at the difference in structure. These are all surface flows now. Look at the difference in structure. That's very important to realize how rapidly system can change out there. And it's also important to realize from the standpoint of chasing the information. We're going to have a picture and we're going to go running down here. I think Stan in his talk mentions that got to remember where we're going. We're going to Bermuda. And sometimes chasing after these elusive flows, high flows, is a fool's errand, hard to realize. Along with these features, there's a number of rings I mentioned earlier. Meanders, top left, slope water, Sargasso seawater, and a meander in the main body of the stream. It used to be that these things were fairly regularly behaved. Nice meander with a snap, like a bullwhip, a snap, and the meander would migrate to the northeast at rates of miles today, 10 miles a day, something like that. We'll see that that's no longer the case. That system is quite a bit more complicated. On occasion, as I said, these meanders, these oxbows in the flow, will pinch off and trap a parcel of, in the center there, SS Sargasso seawater, or down below, shelf water, and produce rings. These rings can have dimensions on the order of 100 miles or so or more, and speeds in there in excess of 3 knots. Again, the structure is very similar to what we saw in the main body of the stream. You got to come in some distance from the edge of the ring. The rings to the north of the stream, the warm core rings to the north of the stream, have a relatively limited life because they tend to run into the edge of the shelf and dissipate. On the other hand, the cold rings to the south can be around for a very long time and are often very difficult to see in satellite imagery because they're a little bit more dense. They're colder water. They're a little more dense than the ambient water, and will tend to sink, and making them very hard to see in the satellite imagery. Okay. Over the past few days, what do we see as we start looking out there? Clouds. And it's a real indication of the value of starting early. Of course, you know, invariably the cloud cover is going to be maximum somewhere around the start of the race. You're going to keep in mind a variety of resources, And that's for you to determine. Everybody comes up, every navigator comes up with his own set of particular links that he likes, with consideration of what do we care about? I got a 50-foot patch of ocean that I'm caring about, and you're giving me kilometer resolution model results, both atmospheric and oceanographic. What do we need for the accuracy? What do I have to get the information? Don't take it for granted. You can get everything from your cell phone or your sat phone. And then sensory overload. If we look at 1,000 sites at home, believe me, you want to go offshore, you want to look at 1 or 2. We try to provide some amount of information on this. You'll have some Gulfstream links. We'll be posting these fairly shortly. This lately is getting to be a real, it's an interesting chore because these things keep changing rapidly. And it's not all Doge. There's a variety of features why. Unfortunately, these 4-day composites aren't currently available, but we're hoping they're going to come back online. But this is the kind of information that you'd like to get. So you can sit and you can take a look at the evolution of the meanders and the change in the position of the stream and possible structure of the stream. We use very often, we go from the satellite imagery to models, and this is the global real-time ocean forecast system from NOAA. And this was on the 5th. And if you compare it to what we showed earlier in the case of the meander, you see there's some indication. This is a currents one. Here's another model. This is the Mercator, my Mercator, Mercator maybe. Less evident of a meander in this. Which one is right? God only knows. You can sit and argue, but that's one of the things we're trying to do, develop confidence in the model that we're using. The best model, in my estimation, is this altimetry-based model. This again is for the 5th of May, and you can see clear evidence. These are now velocities being shown. There's a couple of day delay in all of this, but this is a particularly valuable set of information. I know from having played with this since it came out about 10 years ago or so, that the altimetry-based modeling is very, very good. So and you can see it here. It's a pretty good representation of what that meander is looking like, a pretty good representation. It's quite similar to what you saw in the satellite imagery, the sea surface temperature. But in addition, you'll see that you get information on the flows to the south of the stream down to Bermuda. And if you look here carefully, you'll see that there's a fair amount of adverse flow because of two counter-rotating features sitting down there. So that variety of data of direct observations and model information, you'll compare, just as you compare the model of the weather to the actual weather to gain some confidence in your weather models, you do the same thing with the oceanographic models. As we're doing all of this and thinking about routing, it's very important to remember that the Gulf Stream is a weather breeder. It provides a great source of warm, moist air, which is the gasoline for the atmospheric heat engine. And coming on the stream, you'll usually see a nice stream of clouds, and on occasionally you'll see some thunderstorms, as we show here. So now we take what we're playing with the stream and consider how best to manage all this. I'll pass this on to Chelsea for some discussion of the weather.
Thanks, Frank. That was, yeah, an awesome description of all the main features you really need to know about the Gulf Stream. The Gulf Stream is arguably one of the biggest factors when we're looking at an overall race strategy. So to kind of just tell you a little briefly why this is important, to come up with a plan, come up with a strategy, and start to think about, you know, some of the resources you can use. But just to kind of piggyback on what Frank was saying, and I think this is a key feature when you're thinking about the Gulf Stream, is something called stability. So if you're not sure what like atmospheric stability is, just a real simple concept. Warm air wants to rise, cold air wants to sink, right? When we have cold air coming over a warm surface, you get instability or turbulence. And so that causes essentially what Frank was saying, those thunderstorms, instability. You usually are getting more clouds over the Gulf Stream than you are off the Gulf Stream. So that instability, that turbulence is going to bring up all kinds of weather, and it's also going to make the wind gustier, by the way. So you're going to see wind speed increases up to like 20% higher. And you know, there's so many things to talk about in terms of weather over the Gulf Stream. Other things you might look for are like northerly or northwesterly cold air that's coming over the Gulf Stream could be indicators of like a very strong wind event that could potentially bring high seas. And then of course, wind against current. That's the biggest one that everyone's looking for, is like, is there going to be wind against current over the Gulf Stream? Is there going to be northeast or east winds? So those are all things that you can start, you know, watching for in the weather patterns. So I'm going to talk a little bit less about theory and a little bit more about tools and strategy here, so that you guys can start to think about what your race plan looks like as you get ready. So before the race, this is everything starting from today up until the day before the race next year. So more than 7 days out, this is basically from now until a week before the race next year, you can do route research, some historical analysis. I'm going to talk a little bit more about this in just a minute. And then when we get to within 5 to 7 days, that's what I would consider a long range forecast. The confidence is not super high still at that time in the models, especially in June. I know a lot of people think of June being like summertime pattern, but a lot of times the weather models and the weather patterns in June are still in transition from spring to summer. So confidence, even 5 days out, sometimes is moderate or could be low. Then when we get to within 3 days of the race, you're starting to add in more detail. You're getting higher confidence, especially if the models are starting to line up. That's giving you higher confidence. But this is kind of what I take my clients through this process and teaching them how to make this strategy. And the day before the race is when I do my most of my detailed part of the forecast, and it's when I advise everybody else to kind of spend the most time. So this is when you're doing what I consider basically creating a race playbook. So this is when you're getting all your detailed data in terms of weather and starting to create if-then statements. So basically you're going to gather all the data you need on wind, pressure, the Gulf Stream data that you've already been looking at, and you're starting to create some plan, right? And this is when you're putting it all together. Then race day comes, and hopefully then all you're doing on the morning of is updating that plan. So you're just looking at observations of what's actually happening that morning, doing kind of the last minute model changes that might have happened from the day before, but you don't want to be sitting there on race morning basically putting your routing plan together, right? So we want to do that pretty much the day before, maybe 2 days before at the earliest. And then while racing, I know Stan is going to talk a lot about this, but you're basically just refining that plan, and you're kind of now casting based on what you see. And I call this adjustments based on reality, or ABRs. So basically you're always adjusting that plan, and you're always adjusting it based on what you're actually seeing, either from your boat or from observations that you're getting data wise from other boats or sources. So this is the playbook process that I just kind of mentioned. And again, this is what I teach people how to do all the time for any race, but especially for Bermuda, where there's kind of 3 main sections to the race. There's like up to the stream, crossing the stream, and then there's everything south of the stream. So your first step is gathering data. So that's everything from big picture, frontal systems. We're going to take a look at a map in a second so you can see what I mean in terms of like a synoptic map. And then you're going to go everything all the way down to specific wind speeds, sea state, all of that, for every 3 hours, every step along the way. All right. And then once you have that, you can kind of start to identify what you think the main players are in this particular race, right? So every race, it might be different. Maybe there's a big cold front coming through, or maybe there's no fronts at all, and it's just crossing a big high pressure system. And so basically your job, if you're a navigator or someone working on the strategy, is to identify what those few main players are and the most important ones, because there's going to be a lot of pieces of weather that are happening that maybe aren't important to the strategy. So your job is to kind of succinctly create a little elevator pitch of what the main pieces are, and then make sure you can communicate that to the rest of the crew. And if you can say, hey, the main features are a cold front is going to hit us on the first day. After that, we're going to be pretty much coasting downwind in northerly breeze. And, stream crossing is going to be a little bumpy. And then after that, it's going to smooth out. If you can kind of basically do it in 1 or 2 sentences, it's going to simplify the whole process. And then you, as the navigator, strategist, whatever your job is, can be to go a little bit deeper into the details to figure out what's important and what's not. Right. So then the last piece, or the last 2 pieces, is kind of those critical race points. So like I mentioned, coming up to the stream, crossing the stream, those are big decision points. You have entry and exit points of where ideally you want to go. Maybe you're going to hit the meander. And then anything else like coming into Bermuda, other decisions that you're going to have to make, maybe points in which you're like, okay, we're going to have to change sails at this point. We need to make that call X number of hours in advance. And so once you have those kind of pieces, you can then create your playbook. And so this is essentially just a series of if-then statements, right, based around different outcomes. So the way I do it and teach people how to do it is you're thinking about every possible kind of scenario for around the weather. So if there's a front, what if it's a little faster? What if it's a little slower? How does that change your plan? What if we are faster or slower than what our routing is saying? What if the forecast calls for it to be cloudy, but what if it's not? What if it's clear skies? Is that going to mean that it's windier? Where is the next gradient breeze? That's a really good question to always have in the back of your head. Where is that next weather system coming from? So that way you're not just sort of caught in the moment. You're thinking about what the next, the new wind is and where it's coming from. All right, so that's kind of the big picture of how to put the pieces together. Now let's talk a little bit about the actual tools. So what are some of the tools you can use? I teach the big 3. So there are 3 types of data, and you want to make sure that you're looking into all 3 types. Okay, so the first is analysis, and this is human input. So this is something that a forecaster or a professional has looked at, has touched, has created in some way. So you know that it is distinctly better than a computer model. Okay, and so there's a lot of value in this. And I think anyone who's in the industry would agree that you know, places like Weather Prediction Center, Ocean Prediction Center, National Weather Service, these are all human human input data sources that are important to look at. So personally, I like the Aviation Weather Center Prague chart. If you just Google that, it's the first link that comes up, but it shows you basically an interactive map of the United States and all the different weather fronts on it, and you can zoom in and zoom out, and you can move it forward in time to see how the fronts are moving. So that one is really cool. Ocean Prediction Center is going to be a big one for the Bermuda Race because it covers that whole area. There's also one that comes from Bermuda Weather Center that you can look at. And so that's where I always start, is the analysis section, right? Second piece is models. So this is no human input whatsoever. This is just pure computer models. And this is where most people spend like all of their time, is in the computer model world. And oh, the grid said this and the grid said that. Okay, that's important. We're definitely going to look at that. But I would encourage people to spend time practicing in these other two areas, in studying the analysis of the fronts. I'm going to show you an example in just a second of what that looks like. And also looking at observations, right? So that's what are the winds actually doing, your ground truth. And then things like radar and satellite, you know, as you're able to corroborate what you're seeing on the analysis and corroborate what you're seeing on the models, that is where your value is going to come in, right? So those are your three big sources of data: analysis, models, and observations. So make sure you're dipping into all three buckets. So this is an example of what a surface analysis looks like from Ocean Prediction Center. And I just want to point out a couple of things. Sometimes it can be iffy on when you're looking at a map. Am I looking at an analysis that's been touched by a human, or am I looking at something generated by a computer? So one thing you want to check on is at the top left, or you see here, but sometimes it's at the bottom. So you got to look for a box, but somewhere there's usually a box that will have information about where it comes from and who put it together. So this one actually from OPC, it says forecaster and Bell. So this tells you, okay, a forecaster put this together. It also says analysis right on the top, so that's kind of a giveaway, but it also tells you where the sources are. So, and make sure you're checking the valid time. Make sure this is all up to date. Sometimes you're looking at these and they're like a couple of days old because something's wrong with the website. So check your valid times always. But that's just one giveaway in order to see if what you're looking at has been verified basically by a human, which is important. Okay, I'm going to briefly go through some models. This is a huge topic. You know, I teach a lot of classes that are just on models, but just basically to do an overview, the usual suspects are global models, the GFS, the European or ECMWF. I also have been using the ICON, which is a German model recently. That one's actually pretty good. There are mesoscale models, which are kind of a slightly higher resolution, but not quite as high as the high res. So really the only one we have for that is the NAM, but I will say that one is not as good as it used to be because pretty much the HRR has kind of taken precedence over that one. So I actually usually skip the NAM. I've also found it's not been very accurate lately in the last couple of years. So usually skip the NAM unless it's all I have, and go right to the high res models. And so this would be your HRR and then any proprietary WRF WRF models. So that would be like a predict wind 1 kilometer, Sailflow has a 2 kilometer, they're all pretty good. And you want to make sure you're looking at a variety of different models and that they're saying similar things to gain confidence. The new arrival on the scene is the ECAI forecast system. This is new, and so just all I can really say about it now is that it's unproven, but time will tell. So far, it looks pretty good. It's an AI, improved forecast, but so far it's been good from what I've seen, and it's only been out a little while. So hopefully by next year I'll have an update for you on whether it's actually been good. And then of course we have ensemble modeling, which basically, if you're not familiar, all it is basically like what you see when you see the spaghetti models in a hurricane forecast, where there's all these different possible solutions. So essentially the computer models take the input data and modify it just slightly and produce a multitude of different outcomes depending on that initial input being slightly different. So what this is good for is helping you determine forecast confidence. And so if all of those ensembles are converging to the same solution, it gives you confidence that, hey, this is a pretty high confidence scenario, and we can put good confidence in this particular model, or just this particular weather pattern. But when they're spread out all over the place, it gives you low confidence, right? It can also help show you some inflection points of like, hey, these models are bringing the low pressure this way and the other ones are bringing it this way. So this is a crucial point in time whenever that happens. And so these are accessible on a variety of websites, but I like tropicaltidbits.com is a good one to see the ensemble models if you're not sure where to go to get them, because they can be kind of hard to find. And speaking of where to find all of this stuff, I put together a free weather resource library that you can get. It's on my website. You just go in, put in your email, and you can get all of the links that I use. And there's tons of stuff in there. And I also put some grid files in there for you as well. If you want, I'll share that information in a second. One note about the HRR is that the domain does not go all the way to Bermuda, which is unfortunate. So what it means is that in the last 1/3 of the race, it forces you to basically switch to a global model, which is a lower resolution at a somewhat critical point in the race, which is when you're trying to make that final call into Bermuda and what your strategy is going to be. So what I've done with my clients is run a higher resolution wharf that goes all the way through Bermuda. So it's a 3-kilometer wharf model that takes you all the way there. Which is better because maybe the confidence is lower because it's 4 days out in the future, but at least you have a higher resolution. At least you're kind of cutting out one of those variables in terms of the variables that are being thrown at you, which is you don't have a high resolution model, it's at a critical race point, and it's far out in the future. But at least you're cutting down the resolution by having a higher res model. So if you can get access to a higher res model for that last bit, it's worth doing that if you can. Frank did an awesome job talking about the Gulf Stream and models. One thing that I've just in my personal experience noticed about current models you should know is to lower your expectations, especially if you're dealing with a lot of weather grid files and you're used to a certain level of accuracy in the weather files. We know a lot more about the atmosphere than we do about the ocean. There's just a vast variety of data that's still untapped in the ocean, and we're not gathering that. So anyways, the current models are, if we're lucky, there's one that's maybe kind of sort of right and the other ones are usually kind of out to lunch. We've looked at 4 main models with the HICOM, the RTOPS, the NCOM, and the Mercator. The NCOM on a normal basis seems to be pretty good actually. So that's the one I kind of lean towards, but obviously the other ones on any given day could be better. It's sort of like the weather models, they come and go on which one is doing better. But I totally agree with Frank that what we've actually done with our clients the last 3 Bermuda races, and it's worked well, is use sea surface height, which comes from the altimeter data that he was talking about. And we basically kind of manually propagate any of those features that we're seeing observed on the altimeter to where we think they're going to be right before the race. So if there's an eddy and we know it's moving west at 4 knots, we will just kind of manually extrapolate it west 4 knots so that it's a real feature. We know it's there and this is how it's moving. And then we look at it from there. So that's my best suggestion in terms of what to do there. And then the last bit here is this is stuff that you can start doing now. So pre-race, this is like this summer. You can look at historical weather conditions and patterns. You're mainly looking for where is the Bermuda high, where is the ridge placement, and how that affects your routing. What a good suggestion would be maybe do a mock routing this June. So like on the race day that the race is supposed to be, maybe fire up your laptop and pretend you're starting the race. And then the grid files I was talking to you about, I went ahead and pulled them because they're free from ECMWF. There's reanalysis data that goes back I think to 1940 or 1950. So it goes back quite a ways. But I pulled 30 years of historical data of wind and pressure from June, and I just put it into a GRIB file and put it in the free weather resource library. So if you want that GRIB, you can go get it. But any other historical data you want, you can get from the ERA5 reanalysis from ECMWF. It is a little tricky to kind of get to, so you can contact me if you need help getting it. And then there's past race data and tracking data that you can look at, obviously, and kind of analyze that with the weather patterns. All right, I think I've used up my time. I'll pass it along to Stan, who's going to give you all of the practical information. So, Stan.
Finding the mute button. Thanks. Thank you, Chelsea. That was great. Okay, what are the most important navigation factors? The Gulf Stream obviously is critical, but it's worth keeping in mind that the effect of the Gulf Stream is very different on slower boats versus very fast, high performance boats. The slower boats are in it longer. The velocity of the stream is a large percentage of the speed capability of a slow boat. So it makes an enormous difference to a slow boat. And then for a really fast boat, counterintuitively, you often avoid the favorable current, meaning if it's wind against current and you're going upwind, the sea state slows you down more than the current benefits you, and even going downwind. If it's light air, you avoid the favorable current because you can sail faster than the wind. And so the favorable current reduces your wind. So it's worth keeping track of the kind of boat you're in. But for a slow conventional boat, the stream makes an enormous difference. So in 2022 in our Cal 40, it's absolutely staggeringly important to get the main part of the stream right. It's also worth observing that higher performance boats have wider jibe angles. And so they have the ability to gain leverage on wind shifts for free, and they have the ability downwind to sail farther afield to take advantage of eddies or of the stream itself. Because if you think of the ladder line going downwind, a heavy slow boat like a Cal 40 has to basically go straight downwind, whereas a higher performance boat has wider jibing angles. So you get the ability to go side to side for free. So you can get more leverage in the shifts and you can go hunting down favorable shifts and favorable current. Humans have to assess the uncertainty and the risk. It's worth observing that forecast data obviously is less reliable with time. The forecasts are now very good for a day or two, and they're definitely worth looking at for 4 or 5 days, and then they become mostly fictional from 10 to 15 days. But consider the fact that the routing algorithms don't assess that risk. So if you're doing a transoceanic trip and it's going to take 15 days, the routing algorithm will assign just as much certainty to the forecast 10 to 15 days out as it will assign to the forecast data tomorrow. And of course, that's nonsense. So the humans have to put in that assessment of uncertainty and risk themselves. And humans are good at that. Someday the routing algorithms will be doing that as well. Make sure that you and the crew always know the free advance course. I'm not sure what the best term for that is, but basically it's the course where if you could pick the boat up with a helicopter and move it any direction for 10 miles and put it down in the water, which way would you take the boat? It's often not the direction that you're headed. It's often the direction that's going to be upwind tomorrow or some other reason. But nevertheless, the sophisticated routing programs like Expedition and Adrena give you the ability to plot reverse isochrons, and you can see what that free advance course is. And it's critical for the crew to know what it is, particularly in a Bermuda race where there's a lot of convection. You can get squalls and thunderstorms, and you can suddenly find yourself in a beam reach, and the crew needs to know where to go. What's the optimum direction if you could go anywhere? As a practical matter, what sources to use? HRRR. I tend to be skeptical of the HRRR once it's outside the effects of terrain. So I tend to shift over to the global models once you're well outside the effects of terrain, because the HRRR has a lot of mechanisms built into it to deal with terrain. And in my experience, those mechanisms can cause the model to go off the rails compared to, once you're out into the synoptic weather. Chelsea has a somewhat different opinion. And of course, you'll find that true of anybody, any navigator, any weather. There's a lot of different opinions. So what I do is I tend to shift from the HRRR to a global model once you're well outside of the effects of terrain and you're into the synoptic weather, the weather that's driven by the systems on the weather map, the fronts and the highs and the lows, etc. In terms of the global models, you've got the GFS and the ECMWF. The ECMWF is generally regarded as having a slightly higher level of skill than the GFS, but the GFS has a huge advantage during the race, that it's available more times per day, and it's available about 3.5 hours earlier than the ECMWF for each initialization. So for example, the Zero Zulu models, you can get the GFS 3.5 hours sooner than the ECMWF. And that 3.5 hours is a huge difference. So as a practical matter, you end up not being willing to wait, and you have to make the during the race decisions of, where's your ley line to get to your stream entry, or where's your ley line to get to your stream exit, or where's the ley line into Bermuda. You end up making those decisions based on the GFS, and then you use the ECMWF 3.5 hours later to sort of verify them. And if the ECMWF disagrees, you often decide to wait another 2.5 hours for the next GFS before you decide what to do. Because it's worth observing that for very short forecasts, while the ECMWF does tend to have slightly greater skill than the GFS from an initialization set of data that's 6 hours later makes a bigger difference. And so you tend, even if you're navigating a French boat from shore and you have all the cosmic tools, once you're underway, you tend to use the GFS because it's available more often and sooner. Current, the RTOFS and the Mercator are different models. They're independent. The HICOM and the NCOM are highly correlated to the RTOFS. So I basically just use those two. If those two agree, the RTOFS and the Mercator, then you believe them. If they disagree, then you worry about it and fret and try to work out a logical solution. The solution we came across in 2022 for the Bermuda race was interesting. The RTOFS and the Mercator disagreed. They were entirely different on how they handled the mainstream. On the other hand, the same entry point to the stream was a reasonable solution. So what we did was we just raced to that entry point in the stream. And then once we got there, we measured the direction the stream was going, and we determined that the Mercator was right. So then from that point forward, we used a stream strategy, for the Mercator model. So if the models disagree, you got to try to sort it out. If they agree, you can pretty much take it to the bank. In my experience, don't sail extra miles to optimize for a cold eddy south of the stream. Those things exist. You'll see them. You'll measure the current in them. But in my experience, they're poorly enough forecasts. So you don't want to spend extra miles in order to optimize for them. But it's worth keeping them in mind. And if you're in a situation where you can handle one correctly for free, that's fine. Take advantage of that, but don't expend extra miles. When to start caring. Don't prejudge your race. The 2 or 3 day forecasts are much better than 4 or 5 day forecasts. So the one thing you don't want to do is to get committed to your overall race strategy too many days in advance. But what you do want to do is extensively practice your 6-hourly work cycle of downloading the data, analyzing the weather, looking at the weather maps, then running the routes, then analyzing the routes. And then you should also practice your briefing. And in my view, the key thing to briefing the crew, and the key thing for any navigator, is you have to be able to study the route and to tinker with the route and to tease it around and to try different things until you understand why the route is doing what it's doing, and until you can explain it in sailing terms. Terms like, we're footing to the header and then we're going to attack, or we're going to take advantage of this eddy, or we're heating it up downwind to get to this lift, and then we're going to jive. But if you can't explain it to a sailor in sailing terms, then you don't understand it. And it's absolutely unacceptable if you hear a navigator say things like, well, we got to go here because that's the optimum. You know, there's these thousands of millions of cycles that have taken place. It must be right. You have to tease with it, tinker with it, understand it. And when you understand it, you can explain it in sailing terms. And if you can't explain it in sailing terms, then keep working at it. Do your pre-race practice on board, especially the last week or so, if you possibly can, using the onboard computer and the onboard satellite communications. And that just gives you the familiarity and it uncovers problems early. Routing tools. If you're serious about offshore race navigation, you want to use Expedition or Adrena, and most professional navigators use both. So if you're navigating in a Volvo or a, Vendée Globe or a Ruderam, etc. Those systems are useful to compare weather models. They're useful to answer what-if questions. They're useful to deal with the uncertainty of the weather and to analyze the uncertainty of the weather. They're useful to analyze the sea state sensitivity of different routes and of your boat and of different competitors' tactics. You want to learn to use the reverse and forward isochrons. Both of those systems allow you to display those and look at them. And those are enormously important tools to understand the sensitivity of a course, meaning any router will give you an optimum course, but you got to ask the questions, how important is that? Meaning, how much does it cost to sail a somewhat different course? And you need to have a feel for that in order to decide how much you can optimize for a given thunderstorm as it goes by, etc. And if the course really has a large don't care area, you need to understand why that is. And if it's super important for a course to go in a particular area, you need to understand why that is. And when you understand that, again, you can explain either of those things in sailing terms. The free advanced course, again, is perpendicular to the reverse isochrons, meaning wherever you are, you want to cross those ladder lines as fast as you can. And then the wind will eventually revert to the norm. It'll revert back to the big models. Cheaper alternatives to Expedition and Adrena exist, and they include the ones that I've listed there. I've used Predict Wind Routing, out of curiosity before the trip, but I haven't used the other ones. Take advantage of genuine human intelligence prior to the start. And here's a list, I won't read them all out, but here's a list of well-known contractors, including Chelsea, that can contract out and help you understand the weather and do your homework before the start. So what to do now? Run routes on historical grid files for your boat using your tools. And those historical grid files exist, as Chelsea mentioned. You can get the reanalysis from the ECMWF. You can also get the GFS historical files back to about 2004. Practice thinking of and answering the what-if questions and asking the questions, how important are different parts of the route? Practice your crew briefing. Force yourself to only explain the route using racing terminology. Sometimes it's useful, depending on the boat, to run different polars for your race boat from trial ORR certificates on multiple years of historical grid files in order to understand different boat configurations. So even in our Cal 40, I think I ran many, many hundreds of routes to make decisions on whether you wanted to carry different sail configurations and what would be the optimum racing configuration for that. And so what I would typically do is run 3 routes per year for the last 20 years. I'm starting in the vicinity of the calendar time of the upcoming Bermuda race. Start with the ORR polars and then update the polars to reflect the boat's actual performance if necessary. For conventional boats, the ORR polars are very good, and often all you need to do is an overall scaling, to scale them at 98 or 96. But all routers will give you better advice if you scale the polars so that the boat, for the most part, gets to where the router thinks it will be in the future, because only then will the router advice be actual relevant to the weather forecast. Does FTCF scoring impact your strategy? The answer is no. And the reason it's no is that no matter what the scoring system is, the objective of the navigator and the crew is to finish as soon as possible. And that the scoring system doesn't change that. With FTCF, however, your time allowance relative to other boats is easy to compute because you will get a TCF before the start. So boat-to-boat tactics are practical and far more interesting because you can unambiguously and correctly compute how much time you owe other boats and vice versa. So you can make decisions on board of who to cover and when to split. Whereas in the past, the scoring systems, it wasn't impossible, but it was very challenging to figure out what the time allowances were during the race. So FTCF is terrific for the sailors. It makes the race way more fun. It's also true that with FTCF, more of the fleet will be in the hunt for more of the race. And that also is good for the race and for the fleet. Don't cheat, even inadvertently. And it's easy to cheat inadvertently in terms of the routing. Don't use predict wind routing during the race. Predict wind routing and professional advice is legal before the start, but it's not legal during the race because it violates the prohibition against custom outside assistance. Caution family and friends to never send comments to you about the weather or your route because those could easily be misinterpreted as outside assistance. And be really, really careful of the pitfalls of social media. On the boats that I navigate, I don't allow the crew to use social media on their phone. I don't give them access through Starlink to the internet. And that seems heavy-handed, and I guess it is, but it's far too easy if you have a crew on social media for somebody on the boat to log into a site and have somebody else on the social media site say, I'm thinking you're going to be jibing in 2.5 hours. And well, you just cheated. And so be very careful about that. And it's worth warning the crew that if you are going to let the crew do social media during the race, you just got to be really careful that they don't inadvertently get outside assistance. Those are my comments, Andrew.
Thank you, all three of you, very, very much. What a very big spoonful of advice from each of you. I'm sure there's going to be a lot of requests to see that slide deck, so we probably are going to have to figure out where to post that besides just have the video available. So thank you guys very, very much. A number of questions have come in from the audience, and I prepared a couple myself. So if you guys don't mind, I'll just jump in and throw a couple out there. Frank, one for you. Any macro trends in Gulf Stream behavior? And that's the question really is about year-to-year type of trends that are evident, perhaps related to global warming or other aspects that might become relevant to racing.
We've heard a lot about the possibility of the stream disappearing, so we can leave that one off the table for the moment. Most of those are misstated because we're really talking about something other than the stream. But one thing that we have seen in the last, I'll say 10 years, pick a number, is quite a difference in the behavior of meanders. And the shore folks have seen the product of that in terms of many more warm core rings spinning off and heading up into the Gulf of Maine, where it's now reasonably easy for an old timer to swim in the summer. What do we see? I showed you on in one of the slides the meander that sits in the stream right now. The pictures in the textbook would have that meander migrating off towards the northeast at a fairly regular rate, 10 to 20 miles a day, something like that. We're seeing many of those now staying in place, deepening, and even backing up, that is coming back towards Hatteras, at some point pinching off. So there's been a very real difference in the behavior of meanders in the last 10 years. And it's a feature that really warrants careful examination because, of course, as that meander migrates, it can substantially change the characteristics of the current flows affecting the run line.
Great, thank you for that. One for Stan and Kelsey. You both talk a lot about using models and about the what ifs. So what on a course like the Newport Bermuda Race, what triggers you to suggest when navigators need to consider when to abandon or adjust their grid-informed routing?
I'll take a shot and then Chelsea can correct me. But if the weather you see, you have 100% certainty of that. You know, there's no risk at all with the measurements that you're making. And if that, on the other hand, the weather 24 hours from now, you know, unless you're Bob Rice, you're not as good as the model. So live with it. So what you need to do is you need to figure out how to race in the wet wind you have, but to sort of build in a transition, because 24 hours from now, you're much more likely to be racing in the wind that the model forecast than you are to be racing in the wind that you might guess. So, and then all of the routing tools have tools to do that. You can put in a twist and you can put in a change in wind speed, and then you can guess at the transition, and you can look at the sky. You can try to figure out what's the cause of the difference that you see. You make your best guess at that, you know, typically by looking at the sky and looking at other reports, and then you build in that transition. But it's a mistake to stop looking at the models, because, you know, a year into the, or a day into the future, that model is still the best bet, in spite of the fact that it's wrong right now. And of course, you're going to get updates. You're going to get updates every, you know, within a few hours, most likely.
Got it.
Yeah, I agree with that. I always tell people, don't throw the forecast out. I have had people tell me, oh, well, it was wrong at hour 42, so I just threw the rest of the forecast out. And it's like, don't throw the baby out with the bathwater. This is why we make a plan sort of ahead of time before the race. We have our what ifs, and if it starts to deviate away from what our strategy is and what our models are saying, what our routing is saying, okay, give it time. Like Stan said, it will probably come back. And I always have a rule of thumb too, that, you know, whatever plan I had sort of come up with, you know, when I was clear-headed before I was sleep deprived sitting at the nav station for 2 days, I tend to trust that brain a little more than the brain that's sleep deprived and been getting hit with squalls and stuff. And I'm not just going to restart my whole strategy halfway through the race. So
Go ahead, Frank.
Just real quick, one thing that's important to remember is the resolution of the models that we're dealing with. And you know, you can be the typical models 10 to 20 kilometer resolution, and we care about a 50-foot patch of ocean. And that we don't often get our 3-kilometer resolution from the HRRR when we get offshore. That means that in areas where the flows are quite turbulent, as they tend to be in the vicinity of the stream, sometimes the reality differs substantially from the model because of the model resolution characteristics.
Great, thank you. While we are having questions for Chelsea and Stan, here's another one that came in. What do you think about the NDFD model? I've not heard of that one. It has human forecaster input. Should it be better than the pure computer models?
the
So why don't
NDFD
you swing at that?
is, yeah, it's a good model. And so in my experience, it has some human input. It's basically a model that like the National Weather Service puts out there. I believe the resolution is not as good as even like the ECMWF, and I tend to see it broad brush a lot of weather features. So it's not picking up as well on like localized sea breezes on the smaller scale and some of those micro scale features that things like the HRR are picking up on. So for a broad view, like almost like a lower res global model view, I think it's a good one to add to the mix. But for more micro scale and small scale stuff, I would opt towards HRR.
Yeah, I agree with that. And I've also found it to be somewhat inconsistent.
Got it. Great. Thank you for that. Frank and Stan, a couple questions have come across the transom on this one. In 2024, the FTF scoring used the RTOFS model. There are obviously other models to be used. Why RTOFS versus Mercator when we're generating the time correction factors?
Basically, the RTOS and the Mercator are, in my view, equally good. And it's kind of a toss-up which one you'd pick. You know, any given Sydney Hobart race or any given Bermuda race, you know, it's a 50-50. The advantage of using the RTOS, of picking the RTOS for the use ahead of time, is that you don't want a human to be making that decision. You want it to be disclosed in the notice of race so that it's objective. And then the RTOS model has the virtue that it's free to everybody, it's easy to get, and it's ours. You know, it's a US model. So that's the only reason. But if the Mercator were, you know, were clearly better, then I think we'd want to use it, but it's not. And then frankly, when you rescore previous Bermuda races and you use one or you use the other, it's rarely made a significant difference. But it is true that those models often disagree, and often you have to figure out which is closer.
And I guess to your point earlier about, does TCF scoring affect your strategy and your tactics when you're racing? And the answer is no. So the model that the race committee chooses to score everybody on is irrelevant to what model the navigator should be using to find the fastest route to Bermuda.
Yeah.
That's exactly right. And some
exactly right.
people, may go in and rescore the race and be able to argue at the bar that they would have done better had the notice of race been written differently. But of course, that's going to happen no matter what we do for scoring. So
right. No, I agree with all of that. And remember what it is we're doing. We're trying to come up with a single system for everybody. And that's not routing in the rest. We could get into the accuracy of polars. When we talk ... There's a lot of questions in the whole thing. But I agree with Sven that model right now today, in fact, the NOAA model, or real-time ocean forecast, is a better representation of that meander pattern than is the Mercator. Tomorrow it might be different.
Right. Great. Okay. Well, I think asked and answered on that one. I have one more for Stan. Obviously there's rules about outside help, and the Newport Bermuda Race actually has more specific clarifying distinctions about that. Can you explain why we insist on that distinction about outside help and the use of services like PredictWind, and why it's important to our race and perhaps others?
Well, I think, particularly as a longtime CCA member, as are all of you, I think it's worth observing that one of the important objectives of the CCA through the decades is to stimulate interest in seamanship and navigation. And I think it's a better way to achieve that objective by encouraging people to do more of it, to have more involvement in the routing and the strategy and the tactics and the navigation of their boat on board the boat. And I think we all, kind of dread a future. And I've kind of experienced part of this bad dream when I've been on the shore navigation crew for Gitana 17, doing round the world races. And you've got this shore-based team of 10. And we're telling the guy on board the boat, when to wake up and when to go to sleep and when to tack and when to jibe and when to change sails and when to ease out 4 inches on the Jenniker. And it's just, I dread a future that where our offshore sailing, moves towards that, where there's some intelligence on shore that knows where all the boats are, has the best forecast, and it's telling every boat what to do. And the folks on the boat are competing on the basis of the mechanics of fixing stuff and changing sails, rather than competing as we do now on trimming and steering and navigating and tactics and weather and routing and all the rest. That's a very long-winded answer to your question, so I apologize.
No, it's very good. And I hope that a lot of people listen to this, because as the race chair, I do get a lot of questions about this throughout the cycle. Why can we not use PredictWind during the race? And I might say, PredictWind's a nice resource, and I often use it when I need a quick route and I don't have time to use Expedition, not when I'm racing. So it's great service, but it's important for our racers to know that while we're racing, we use onboard tools. Yeah. So thank you for helping explain that. And hopefully that helps answer the question that comes up.
And I'd also like to sing the praises of PredictWind. Meaning, I've been a pro member for as long as I can remember, and I love the way they can render forecasts, it's fabulous. So, but I also would like to see our sport continue to have that sort of focus on seamanship that we've
Yeah.
had forever.
Right. And I think we're making also a very subtle distinction here that's very important to the race. A lot of people pay for predict wind data. You just have to uncheck the box when they send the data, don't send me the route, right? So I think that's really the subtlety that we want to make sure is very well understood. Great. While I search through the list of questions I had and those that have come in, do you guys have any questions for each other, since you all were sitting here and might have been inspired by one of the other presentations?
I've got a question for Chelsea. Is that fair game?
Please.
So Chelsea, my understanding was that HICOM is a higher resolution version of NCOM, and that HICOM is integrated into RTOS. But it sounds like you use, even if that were the case, you continue to use HICOM and NCOM by themselves. I was just curious as to why.
Yeah, it is a good question, because I'm not super well versed on how HICOM is different from NCOM versus RTOS, and I know they're slightly different variations. So that was going to be actually a question I was going to ask Frank. But just independently, I've downloaded the different grid files and just been verifying them against observations the last few Bermuda races. And several times the NCOM was quite close. And then for just my delivery routings and stuff, north and south across the Bermuda, NCOM, at least just anecdotally matches reality a little more often than the RTOPS for me, but that could just be anecdotal of when I'm using it happens to work. But I agree about the comments between Mercator and RTOPS both being a toss-up as to which one is good, because I've seen both work as well. And just so happens that when the RTOPS NCOM HICOM blend is doing well, it seems like the NCOM for me has been better. But yeah, I'm open to hearing other perspectives too. Frank, do you know more about how the NCOM and RTOPS are related?
I have to say tonight, in the interest of time, that I do, but I'm not up to date. The collaboration between the Navy and NOAA is a difficult subject to explain in 25 words or less, if I had the 25 words or less, because it's gotten quite complex. And you notice, if you took a look at the old Gulfstream images from the Navy, that for a fair amount of time, that site has not been on my links because they haven't been updating it. And the collaboration seems to have broken down. Well, they're back on the air again. And another, so this is a bit of a movable feast right now. So there are some differences in formulation, very, very slight in the structure of the model. There may be some differences in the assimilation of data that may be more essential. And that bears on the collaboration between the Navy and NOAA, and I can't really speak to that.
Yeah, that seems to be what I remember too. And there's a frequency issue with some of the Navy data and Navy models, that it tends to be very outdated, and they're not updating as frequently. So I find that I'm getting the NCOM more frequently. Yeah.
Right.
Great.
This is a little bit of the problem that we have right now, and I mentioned it when we're dealing with links. The 4-day composite from OPC, for example, has been off the air for a little bit of time now, getting on a couple of months, because of data passing from one group, census in NOAA, down to another, and that sort of thing. Well, the same thing is going with the Navy. There's a lot of internation swapping of systems and the rest that, for the user at least, appears complex. Now, the fellow that's sitting in Washington or somewhere, in the Navy lab somewhere, may not see it as all that complex, but the general user, both to some extent, I can criticize NOAA and the National Weather Service, OPC, for the sensitivity to the user group. And I can say the same thing in spades to the Navy, civilian user group.
All right. Frank has spoken. Thank you. I think that covers most of the questions that came from the audience, and I've gone through my list. Do you guys have any other quick comments, or shall we close for the evening?
There are
Just a
no
big thank you.
questions. There are no questions that can't be asked. The only dumb question is no question when you really have a question. So by some standards, I made the mistake of putting a link at the top of the presentation. Please don't hesitate to use it. We're happy to answer the questions if we can. And the same thing goes, I'm sure Brock website has all of the contacts as well.
We do, and we're going to put your home phone number on that too, Frank.
Go too far now.
All right. Well, I'd like to thank the audience for joining us this evening, and also for our talented panelists for generously sharing their hard-earned wisdom with all of us. We're grateful that you were willing and able to join us this evening. So thank you guys very much. Please join us next month on June 18th, just before entry opens on the 20th for our 2026 race. The June webinar will focus on the 2026 NOR, NBR-SRs, and on the entry system to help make administration part of your race a little bit more simple. So thanks. We'll see you in June, and